Welcome to this video on barriers to circularity in healthcare. My name is Charlotte van Katz and I'm an industrial designer at the TU Delft, working on sustainable healthcare projects such as the DesHealth and the DICE project. These are European projects that support sustainable innovation in healthcare. By now, you may already know the different circular R strategies, like reuse, repair, refurbishment, and recycling. And you might think, great, let's design a sustainable product. But in reality, circular healthcare is not that simple. We need to ask ourselves, why is sustainable innovation in healthcare so complex? Healthcare is a sector with strict rules, high safety standards, and many stakeholders. And with these many sides to healthcare comes a range of barriers. To design sustainable medical devices successfully, we first need to understand these barriers and acknowledge them through design to overcome them. Research on sustainability in healthcare and expert interviews show 6 main categories to common barriers. These are listed here from most occurring to least visible. There are safety barriers, systemic barriers, regulatory barriers, financial barriers, technological barriers, and social barriers. Let's go through them one by one. The most common barrier is safety. In healthcare, safety comes first, and for good reason. People worry about infection, risks, contamination, reliability, and product performance. Because of this, many medical products are still single-use, even products with valuable materials or electronics inside. Reusable products may also undergo excessive decontamination processes that increase their environmental impact and can shorten their product lifespan. It's important to note that there's a difference between real safety risks and perceived safety risks. A reused or refurbished device with an appropriate decontamination method may actually be safe, but users may still feel less secure using it. This is why transparency and evidence are important. Designers should think about the full life cycle of a product and also about how users perceive safety. The second category is systemic barriers. Healthcare systems are complicated. Many different stakeholders are involved. Hospitals, suppliers, manufacturers, cleaning services, waste processors, policymakers, and more. For circular systems to work, it requires collaboration across all stakeholders, and that is often difficult. For example, reusable products need systems for collection, transport, sorting, cleaning, and redistribution. But these logistical systems are often not yet in place, or they are fragmented and inefficient. Waste separation can also be difficult, which makes recycling harder. This means circularity is not only a design challenge, it is also a systems challenge. The next barrier is regulation. Medical devices must follow strict regulations to ensure safety and quality. And while these regulations are essential, they unintentionally complicate circular practices. For example, reused or refurbished devices may need extra testing or certification. Manufacturers can also face legal uncertainty regarding liability and responsibility when products are reused and repaired. In some cases, regulations were originally written for linear product systems and do not yet support circular business models. This highlights the need for policymakers, healthcare providers, and the industry to work together towards regulations that support both safety and sustainability. Financial barriers are also a big role. Circular systems require investments in redesign, infrastructure, logistics, and training. At the same time, the benefits are not always shared equally among stakeholders. For example, a hospital may need to invest money up front, while environmental benefits are shared by the society as a whole. Current procurement systems can also prioritize short-term product costs over long-term environmental impact. This can make sustainable options seem more expensive, even when they reduce impact over time. Technological barriers relate to the characteristics of medical devices themselves. Some devices are simply difficult to repair, disassemble, sterilize, or recycle because of the materials used or the way products are assembled. Products may contain mixed materials, electronics, adhesives, or components that degrade during sterilization. This means designers play an important role in enabling circularity from the start, for example, by designing products that are modular, repairable, cleanable, and easier to disassemble at end of life. Finally, there are social barriers. Circular economy concepts can be unfamiliar and seem overly complex to healthcare professionals, organizations, and patients. There may be limited awareness about the environmental impacts of medical devices or uncertainty about how circular strategies can be implemented in practice. Resistance to change, lack of training, and limited communication between stakeholders can all slow down adoption. This makes education, collaboration, and knowledge sharing essential for accelerating circular healthcare. So, what can we learn from these barriers? Circularity in healthcare is not only about designing better products, it also requires changes in systems, regulations, business model, and user behavior. For designers, this means taking a holistic approach, considering safety, logistics, regulations, materials, stakeholders, and user perception through the entire product lifecycle. Understanding these barriers is the first step towards overcoming them and towards creating healthcare systems that can be both sustainable and safe. Thank you for watching.